let's look at some apps. We are on the sections 8.7 and 8.8, page 31. Okay, we have been doing what? Rational equations. We did basic skills, add, subtract, multiply, and divide, right? We also did what? Solving rational equations. Now let's look some apps. So before we look at some apps, and there is a shortcut to solve rational equations. They are something called proportions, okay? So let's talk about what are proportions first. So proportion means what? Proportion, right? So portions are similar to the concepts of ratio. So let's talk about ratios first. Ratio, right? Say, okay, my salary and his salary, the ratio is 1 to 2. Means what? I only make half of that person makes, right? So you are doing the comparison. So ratio is what? The quotient of two numbers or quantities. While comparing two things, okay? So we write a certain way, okay? So like we can write it this way. The ratio of 2 to 5, right? Compare two things, and can be written this way as well. Can be written as what? 2 to 5. That means what? 2/5 of that much. Okay? That's the symbols we use for a ratio. And another thing is called proportion. Right? It's a something portion. Is what we are talking about. It's an equation. This one, just two things compare, become a fraction, right? It's a number. But proportion is what? It's an equation in which two ratios are equal. Okay? That means what? It's an equation. You must have what? Equal sign. Like 1/2 and 4/8 are the same. Or we can write x over 5 with variable it is the same as 7/8. Okay? Proportion means what? Two portions are the same. Same means equal sign, right? Two portions are the same. Then we call it what? The proportion. So, it's a fraction thing, right? It's a fraction thing. So, we are going to do rational equations. Means what? Rational, ratio thing, okay? So, before we solve some rational equations for the apps, Okay, we are going to do proportion first because rational equations can be complicated more than a single fraction on either side, right? So we do the simple one first. So how are we going to do the proportion? Let's see. So if I have AB equals CD, okay, let's take a look some examples. So it's a half equals 2/4, right? Is 1/2 equals what? Say 5/10, right? Is 2/4 equals 5/10? Yes, because both are half. So when we have this, take a look at the characteristic of those. 2 times 2 is what? 4. 1 times 4 is what? 4. Are they the same? How about this one? 1 times 10 is 10. 2 times 5 is what? 10. Are they the same? Right? 4 times 5 is 20. 2 times 10 is what? 20. Are they the same? If you have a proportion, you have two portions are the same. When you cross multiplying, you will have same number, right? Or we can call it what? Hot dog method. Formally, we call it cross multiplying, but for you to remember easily, so we say hot dog method. So if I have a proportion, two portions are the same, then if I use cross multiplying, I must have what? AD equals what? BC, right? Then we can do this way, then we can solve problems because instead of fractions, and I can just do cross multiplying. So let's see some examples. So if I have 3/4, 3x, 3 over x equals what? 4/5, right? Then when we solve it, we know we will have what? Some kind of restrictions, right? Because x is in the denominator position. So your x must be what? Some numbers except 0, right? Like before, if we use the traditional way we have been doing for rational equations, is this a rational thing, right? And is this a rational equation? Yes, because of fractions, right? So if we did it before, the method 1, the way we do it is what? Make the same denominator, right? 5 and x is what? 5x, right? Then this one would be multiplied by 5. That would be 15. This one would be multiplied by x. That would be 4x, right? Then we say if we have same denominators, we can just make the numerator equivalent, right? Then you divide it by 4, x will be what? 15/4. And it's now 0, so we can circle the answer. That's the old way using what? LCD, right? It will always work because it's what? A rational equation, so you can always use LCD. Now we are learning the new method. So it's the shortcut. If it is a what? Proportion, because you already have a single fraction on either side, then you can just do what? The hot dog method or cross multiplying. If we do that, then 5 times 3 is what? 15. 4 times x is 4x. Is that right? Then you divide it by 4. X is what? 15/4. You have same answer. Then this method is what? Quicker. And it is just shortcut. Okay? Because if you have simpler form, you can just do that. Look, the next example, we have 3/8 equals 63 over x. So, do I have a rational equation? Yes. So my x is some kind of number. X equals some numbers, and except of what? 0. Right? Denominator cannot be 0. And it is a rational equation. Then you decide if you can use shortcut. So take a look. Is a proportion? So I can just use shortcut. So I do that. 3x equals 8 times 63, which is, let me see, I have a number here, 504. Then I divide it by 3, x is what? 168. Can I circle the answer? Because it's not 0. Right? So we are doing the proportion, which is a special case of the rational equations. It's just a shortcut. Okay? So look at the next one. Equals x minus 3 and 5. Can I use the shortcut? Yes. Right? Because it is a proportion. Two portions are the same. So I will do here, that would be 5 times 2x plus 1 should be the same as 7 times x minus 3. Right? Then I simplify them. 5, distribute them. So 21, right? And minus 5. It's a linear equation, right? Equals 7x minus 26. Is that right? Minus 7x. So I will have what? 3x equals negative 26. X would be what? Divided by 3. Can I circle the answer? Do I have restrictions for x? X is not in the denominator, so you don't have restrictions. So that would be your answer. Right? We are just doing the what? A shortcut for rational equations. But it's just much easier if you have a simple equations, right? Fractions. You can just do that. Let's see. Next one on your page 32. Using proportions to solve problems. So those are just skills, right? Techniques we just learned, and now see if we can do the apps for the problem solving, right? First one, the directions for a certain bug spray concentrate, right, are to mix what? 3 ounces of concentrate with what? 2 gallons of water. Then how many concentrate we need for the 5 gallons of water, right? Should we make a proportions? Because 2 portions should be the same. If you put the 3 ounces to the 2 gallons of water, right? Then if you put too much for the 5 gallons of water, then you will what? Smell bad, right? If you put too little, then you will not be so effective. So we want to make proportionally the same as the instructions on the label, right? So for the things we don't know, usually we use what? X. So if we mix X ounces of, concentrate to 5 gallons of water, it should be proportionally same as 3 ounces to 2 gallons, right? So ounce to ounce, gallon to gallon. That's how you write your proportion. So 2 portions are the same, then we use shortcut. So that would be what? 2x equals what? 3 times 5, 15. Then your x will be what? 7.5 ounces, right? Of the concentrate for 5 gallons of water, right? Let's look at the next one. On an architect's blueprint, so he matches 1 inch of the on the paper, right? Corresponds to what? Corresponds to 4 feet of real thing. So if the length of the wall represented by a line was what? If he wrote something like 378 inches, how many blueprint? Okay, for that actually is. Okay, so 378 inches will be on the blueprint. Then what's the length of a wall actually is, right? 1 inch represent what? 4 feet. So you do 1 inch represent 4 feet, represents 4 feet. So what do you think? 378 inches should represent how many feet? So you write the x feet, right? So do we have a proportion? So what do we do? Use shortcut. X equals what? 4 times 378 for the fractions. So you change the mixed number to improper fraction. So that will be 3 times 824 plus 731 times 8. So then you put a 1 underneath, cross cancel. So that will be 31 over 2, which is equivalent of what? 15.5 of what? Goats? Dollars? No, we are talking about what? The actual wall. It is, right? So that would be 15.5 feet. Good? Let's look at the next portion, which is different type of the one question, which is about distance. Okay, let's see what we are talking about. So, if you travel to San Francisco, if you drive, say, 50 miles per hour for 4 hours, how far did you drive? 200 miles, right? So what do you have? Your speed times the time will be your distance, right? Speed times time is what? Distance, right? If you drive to San Francisco 200 miles in 2 hours without being caught, what do you think your speed would be? So you say, oh, divided by 2, that would be 100 miles per hour, right? So you will have what? Your distance divided by time would be what? Your speed, right? If it's during the, raining days, during a raining day and or a snow day, it took you 5 hours to get there for 200 miles. What do you think? What's your, speed? That would be what? 200 divided by 5. That would be 40 miles per hour, right? So, if, say, your driving speed during the snow day is 40 miles per hour, then how long it would take you to San Francisco? So you would be what? If you drive 40 miles per hour, right? So you divide it, it would take you what? 5 hours. So to find the time, that would be D divided by what? Your speed is what? Your time. Is that right? So what we do is this way. Usually we write what? Distance is your rate times time, right? Or I can just write, so say RT equals D. If I want to get R by itself, how would I do? I would divide it by T, right? So I will have what? R equals D over T. That would be that one, right? So if RT is D, if I want to get T by itself, then I would divide it by R, then T would be what? D over R. That would be your formula, right? So we want to find it individually, so usually you would write a what? Distance equals R times T. So we call it third formula, right? Then R is what? D divided by T. T is what? D divided by R. So that's the formulas you will remember. As long as you remember the third formula, distance equals what? Rate times time. Then you can derive the rest of formulas, right? So let's practice some distance thing. Okay, take a look. First one, on your page 32, we say a car travels 600 miles in the same time that a motorcycle travels 450 miles. Okay, so a car travels 600 miles, right? If you are in the car. Okay, so it's the same time, and motorcycle will travel 450 miles from here, right? So say you start from here, then with your cousin, start from his home, then you want to reach the same destination. It would, for you to drive 600 miles, for your cousin, he needs to drive 450 miles. But you want to reach at the same time, right? And I mean, you will spend same time to reach the place you want to meet. Then you can start at the same time and you will reach at the same time. But you two drive different distance, right? That's what it's saying. Say if your speed is 15 miles per hour quicker than your cousin, right? Then we say how fast you both drive. We wonder, right? So for the distance question, that's what we do. Okay, you do this way. First, you will identify things needed with just one variable. You don't know how to solve two variables yet. Just do one variable. Then you will write down everything you know of the situation. It's only spreadsheet like, okay? So you do your analysis. So you do this way. So you do what? RTD, because R times T is D, right? And R is what? Speed, miles per hour. Then T is what? Your time by the hours. D is the miles, the distance. So you write the things you are going to calculate on the top. Then you write different conditions, different situations, different scenarios on the bottom, right? One is what? By car, one is by motorcycle, right? So what are we going to find? Find the speed of car and the speed of motorcycle. Do we know the speed of the car or the motorcycle? No. So for the things we don't know, we use what? X. So if you put the X for the car, what do you think? What's the speed of motorcycle? Don't put a Y there, right? We can only use what? One variable. But we know, look at the question, the car's speed is 15 miles per hour more than the motorcycles. So motorcycle is what? Slower than a car by 15 miles per hour. So motorcycle would be what? X minus 15, right? And it says it takes same time. We don't know really, but we don't want to use Y. Okay, let's see what will happen. So do we know the miles? Each thing takes, right? So car is what? 600 miles. Motorcycle is 450. By doing that, we only have one variable, but from the formula, we should know how to find the t. T is what? D divided by R. So it's a 600 over x. This one would be what? 450 over what? X minus 15, right? So we can fill in the blanks this way. Okay? Then, first one, you identify things needed with just one variable. Then second step, what you would do, write the equation. So the question tells you something is the same, right? Same time. So you can write what? 600 over x equals what? 450 over x minus 15, right? So do we have a rational equation? Yes. Can we use shortcut? Yes, because it is a proportion. Two portions are the same. So we can just use shortcut to solve the equation, right? Equals x times, oh, that would be 450x. A linear equation. So you have 600x minus what? 9,000, right? 9,000 equals 450x, right? Then you add the 9,000 on both sides. So what do we have? 600x equals 450x plus 9,000. Then move x over, right? What do we have? We have 150x equals 9,000. Then divided by 150, x is what? 60. What does 60 mean? Goats or dollars? Neither, because we say x is what? The speed of the car. So that would be what? Miles per hour for car. For the car, right? Then what's your motorcycle's speed? So motorcycle would be what? 15 miles per hour less. So that would be what? 45 miles per hour for the motorcycle. Right? That's how you solve the problems. For the third problems, you can just say identify things first, write the equation, right? Then solve the equation. Are we good? Let's look at another third problem on your page 33. It says, a cyclist rode the first 20-mile portion of his workout at a constant speed. First 20 miles. Then for the 60-mile cool-down portion of his workout, he reduced his speed by 2 miles per hour. Right? Slower during the what? Cool-down time. Each portion of the workout took the same time. Find the cyclist's speed during the first portion and during the cool-down portion. So we will do the same thing as this, right? So first, what do? We will identify things needed with how many variables? One variable, right? Then we do the analysis table like spreadsheet. So what's put on the top? The calculations need to be done. Then you put on the top the formulas. So you do what? RTD, right? You put a multiplication at the end. So it's a bigger number, then you do things in between. Then two scenarios are what? First portion and second portion. Slow down, cool down period, right? So do we know the speed? No. So for the things we don't know, we use what? X. If first portion is X miles per hour, second portion would be what on your paper? Cool down time would be what? 2 miles per hour slower. Reduce the 2 miles per hour, right? So that would be X minus 2. So do we know the time? No. Then we see what happened. But we do know the distance. Distance will be what? 20 miles for the first part and 16 miles for the second part. Then by calculations, by the formula, so we should know how to do the T. T equals what? D divided by R. 20 divided by X. This will be 16 divided by X minus 2, right? That's first step. Second step, we say what? Write the equation. So it says what? They take the same time, right? Let's see. Each portion of the workout took the same time. So you know the times are the same. So you have 20 over X equals what? 16 over X minus 2, right? Then third step, you will solve it. Solve the proportion. Can we use shortcut? Because it's proportion. So we do that. So that would be 20 times X minus 2 equals 16 times X, right? Then we distribute, then 20X minus 40 equals 16X. Then minus 16X on either side. That would be 4X minus 40 equals 0, right? Plus 40. So 4X equals 40. Then X is what? 10. What does 10 mean? You look at your thing, right? Means what? For the first portion of the what? Speed. So that would be what? 10 miles per hour for the first portion. Then second portion would be what? Cool down portion would be what? 2 miles less. That would be 8 miles per hour. So that would be first portion. Then this would be what? Second portion. Is that right? So that's how you will do the third problem, distance problem. Got idea? So first, you identify things you needed with one variable. So you do your spreadsheet type of table, right? Then second one, you match with the question, what kind of things are the same? So you write your equation that way. Then after that, you define. Then you can solve it. Then find the answer. Then you answer the questions by doing what? Look at the what does X mean, right? Are we good? Let's look another kind of problems, okay? It's work problems. So if we have two persons work together, so see how it works out. Okay, so look at your page 33. If I have two persons to work on one job, so one is the entire work. okay, to be completed. Or we can say being completed. Okay, say you and your friend, okay, work together to stock the bar, you know, different liquors, all that. One person takes, say, 10 hours to do it by himself. Then another person will just finish in 8 hours. If we put 2 persons together to finish the job, how long it will take? So if you manage the bar, then you have a rough idea what will happen, right? How much you have to pay for doing the job. So we started from one person, okay? Say if it takes you 8 hours to finish, then 1 hour, how much you can finish, right? Total is 8 hours. Then 1 hour, then you can do what? 1/8 of that much, right? If 2 hours, that would be what? 2 out of 8, right? Because 1 hour, so whole thing is 8 hours. Then for one job. Then 2 hours, you can only do what? Quarter, right? If it's 4 hours, you will finish what? Half of the job, right? If it's 8 hours, how much you can finish? You can finish the whole thing, right? You can finish quarter, half, and the whole thing. The one we want to use is if you don't know, we are going to find out how long it takes a person to finish altogether for X hours, right? We have to handle the variable unknown. That will be what? X over 8. If it's 8 hours, we are going to use this to solve problems. Okay? So you look the example on your page 34 for the first one. So this one, if say you do it, you can start the bar for 8 hours, right? For 8 hours. And your friend can do it by 10 hours by himself. If you do it together, what do you think? How long it will take? 9 hours? Not really. If 9 hours, you don't have to have your friend. Then you just do it by yourself, 8 hours. So the thinking goes like this. So if you both work together, so you do half, he does half. So it takes you 4 hours to do the half, takes him 5 hours to do the half. Then when you finish, you will continue to work for him, with him, right? So that would be what? The answer would be what? Between 4 to 5 hours, right? Maybe 4.5, around somewhere there, less than 4.5 hours, right? So that's how you look at it. First, you identify, as usual, you identify things needed. With how many variables? 1 variable, right? So we say, what was the question? The question is how long it will take for both of you work together to finish the job, right? Then we know job is what? Job is 1, right? Job is 1, right? Then we say, for how long? So you say it will take X equals the hour together hours needed to finish the job together, right? Then next step would be what? We say write the equation. So equations would be what? The job done by you and the job done by your friend, right? Total should be what? 1. In X hour, you finish the job. So job done by you will be what? You do it by what? You will do it in 8 hours. Your friend will do a whole thing in 10 hours. So job done by you will be what? In total will be what? X over 8, right? By your friend will be what? 1 hour will be 1/10, 2 hours will be 2/10. X hour will be what? X tenths, right? So you add them together will be equal 1, will be, right? Equal to 1. Then you can solve it. So you have a rational equation, then you solve it, right? So you do what? 40x times 5, right? Times 5. Then this 140 will be times 4. That would be 4x equals 1. Then we do the 40, that would be 40, right? Then what do we have? 9x equals 40. Then your x divided by 9 will be what? 40 over 9. That would be 4 hours and 4 nights, right? So it's about what? 4.4 hours. It's less than 4.5 hours. Got idea? Right? That's how you solve the job problem like those. Okay? Let's look another one. So 2 persons volunteer at a local recycling plant. Okay? 1 person can do it in 2 hours. Say you can do it in 2 hours, right? Then your friend can do it in what? 3 hours. Say your friend can do it in 3 hours. So how much it will take for both of you do it together? So half will be 1 hour for you, half will be what? Hour and a half for your friend. So the together will be what? Will be between hour and a half, right? Should be less than hour and a half because you can do faster in half hour, right? So you kind of get an idea the answer, what the answer should look like. So first we do the same thing. Job is 1, right? Job is 1. Then you identify things you needed with 1 variable, right? So you will do what? You will say it takes X hour. So that's the hours needed to finish the job together, right? Right? The next thing would be what? You write your equation. So it say the job done by you to finish, right? You can do it in 2 hours. Then job done by your friend. Then if she can finish in 3 hours, right? Then for X hours, how much can be done by each of you? So 1 hour would be half, 2 hours would be 2 halves. That would be 1, right? So for X hours, so your X divided by 2. So whole thing is 2 hours. Then X hours, you can do portion of 2 hours. So X over 2, right? If your friend can do it in 3 hours, then in X hours will be portion of 3 hours, right? If you do it together, you want to finish the whole thing, that should be 1, right? So that's how you write your equation. Then you try to solve it, then make it the same denominator. So that's 3x is times 2, 2x equals what? Use the LCD here, equals 6. So that would be 5x 6, right? So what do you have? 5x equals 6. Then x is what? 6 over 5. Then which is, we use decimal here, so easier to connect, right? So it's what? 1.2 hours for both of you to do it together. So it's between hour and hour and a half, right? So we just did what? Work problems to finish the work together. Okay, so mainly we focus on 2 types of problem for you to practice. One is what? The dirt problems. Another one is what? Job problems. Okay? And for your next page, page 35, for example 3, we are going to skip. Okay? If you are interested, then you can look at the answer keys and to figure out just but usually we don't have to worry about this kind of problem for you to practice for now, for this class. Okay, so that would be our sections 8.7 and 8.8. That would be our chapter 8. Okay, then next time we do the review 2, then get you ready for your exam 2.